So, hi, Thorsten. Good to see you.
Oh,
You really surprised me with a new paper. I mean, we know you as a professor of mathematical finance at Freiburg University and also as a senior expert in financial engineer at Math Finance. So you've seen a lot, and now there's a new paper that I spotted, which is called Term Structure Modeling with Overnight Rates Beyond Stochastic Continuity. So what is this paper about?
yes, that's a very good question. It actually turned out quite a while ago that while after the cease of the LIBOR, which we all have heard about, replacements of the LIBOR have to come up. And these are so-called overnight rates. And when I first heard about this, I thought, okay, overnights are systematically different from what we have seen in classical interest rate theory. And that's really worth looking at. So from the title, term structure modeling, that's something where you might say, okay, that's where
That's
term
a classic, right? We've done term
quite
structure
classic.
modeling for
Yeah.
decades now,
Then
right?
you have the overnight rates, and then you have stochastic discontinuities. That's a subject where I have been working on the last 5-6 years in credit risk, for example, and multiple yield curves. But now, since you have overnight rates, it means that your bank account rolls over from today to tomorrow, and every day you get a new overnight rate. So you have automatically these jumps every day, and these are, of course, discontinuities, jumps, but at time points where you actually know exactly when the jump occurs. And so I thought, okay, when you have these overnight rates, then you have to rewrite the whole term structure theory, because if you look at the bank account, this is typically an absolutely continuous process, no jump. Even if the short rate jumps, there's no jump in the bank account. And so you have to rewind the theory. And then I asked my colleagues, Claudio, Fontana, and Zorana, Grbac, don't you want to join in? And this was 1.5 years ago. And then since then, we have done a really hard work to bring up term structure theory, like when is such a model free of arbitrage? This was our first question, but towards practical applications, we thought, okay, can we write down a general affine model or setting where we have general modeling tools for such term structures with overnight rates, and then we studied these stylized facts. So what changes actually when you have an overnight rate? And if you look a little bit in the history of overnight rates, this is a short history, so we don't have long data, but what is apparent that you have spikes, quite high spikes, and these spikes occur at times where you expect liquidity squeezes and such. So it's stochastic.
That's what we typically see in equity markets, liquidity squeezes. So
Right.
when you write beyond stochastic continuity, you actually mean discontinuity.
Yes. Beyond stochastic continuity means like if you have a jump like a Poisson jump, a jump from a Poisson process, this really comes as a surprise, right? So anytime you can expect the jumps every second, and so you don't see a high likelihood, or let's say even a positive likelihood on a fixed date. And stochastic discontinuity means, okay, I know tomorrow at 3 I expect a jump, or when I get the new overnight, I know exactly there comes the new information. It might be that the overnight rate doesn't change, so then everything remains like it is. But if there's an update in the overnight rate, so everything has to be adjusted, and this is such a jump.
Right, so you know the times, but you don't know the sizes up front. Okay,
Exactly.
so that's interesting because I mean we know that Freiburg there is a long history of jump
Yeah.
modeling. So you're right in that track. Okay, that's very nice. And I've spotted a closed form solution towards the end of the paper. What is that about?
Right. So now we have these kind of general affine models, but then we thought, okay, for practical use, it would be very interesting to come up with simple models like a Vasicek model where you have such jumps and spikes. And this is actually not so easy to introduce a Vasicek model, and you have a jump at a fixed time point, and then you have the mean reversion, okay, and then the decay. So you get the spike. But
Right.
mean reversion level, mean reversion speed should not be the classical mean reversion speed, because this is slow. So we have a number of factors. One is for the spikes, and one is for the classical mean reversion. And then we also introduced spike to a new jumps to a new level, right? So if the interest rate changes, then of course the overnight rate jumps to a new level and doesn't spike back. So it remains on the new level, and everything can be done fully explicit in a kind of extended Vasicek, or let's say with a term structure like an extended Halbite model. And there we have Black-Scholes-like formula.
For which products?
Let's say for small classical products like caplets, or yeah.
So caplets, okay, so your closed form solution. I think this might actually be of interest for practitioners. Have you seen, what's your monitoring of the interest of the paper? I mean, I can imagine that after the library form, people are dying to get something written down that they can use. How many downloads did you get?
Yes, actually, it turns out that now we have the paper on SSRN and we have 60 downloads in 5 days. So that's a record on my papers. And I have the feeling that this is very interesting to many people who now look for changes after the library form. And we also have hedging results. So in this kind of affine pricing framework, we have explicit hedging formulae taking stochastic discontinuities into account. And I think that's more or less the first time where you have really explicit hedging formulae for such kind of models.
That's interesting. So you got me the Vasicek as a base, which means you allow negative rates, right?
Yeah,
and
negative rates
plus an overlay of jumps, but at deterministic times. So that still allows you closed form solution for basic products at least, maybe more.
Yeah, of course, if you want to have Coxingers or Ross-like formulae, that's also possible, but this may be left for future research.
No, I think it's good because I mean we are still looking at modeling also negative rates. So I think this is pretty much in line now. A lot of people are working with extended versions of Halbite / Vasicek models. So if we add the discontinuities to it, that's sounds really helpful also for practitioners and will inspire future research, I'm sure. Will you give a talk about this at any time?
Oh yes, I think in 3rd of March, I'm invited at the ETH in the Math Finance Seminar to give a presentation on the recent results I have there, and I look very much forward to it.
Oh, great. Well, good luck. I'm sure you'll find a big audience. So, okay, great. Thank you very much, Thorsten. So that's very inspiring. Good luck with your future work.
Oh, my pleasure.